In Module 7, Lesson 7, we're going to learn to write and solve one-step multiplication and division inequalities. According to the pacing guide, we're looking at a 2-day lesson. It has 22 slides, so that's probably going to be pretty accurate here. We're going to skip forward to the first explore, where we're going to use a sketch pad to explore the concept of what happens if you were to multiply or divide both sides of the inequality by the same positive number. So let's take a look at that. Here we're going to take and say, all right, Lamar, Oscar, and Nick are comparing the amount of money they have in their pockets. And you can see you've got Lamar has $3.16, Oscar has $3.88, and Nick, he's a poor fella, he only has $2.20 in his pocket. So we can take and say the divided inequality compares the amount of money Lamar has to the amount that Nick has. Well, Lamar has more money than Nick, so Lamar is going to be $3.16 compared to Nick's $2.20. Check the answer, and a check. So there we've got an inequality where we've said that Lamar is greater than Nick. At least his bank account is, or his pocket account is. Moving forward from there, what would happen if we were to take those values and divide by 2? Watch your sign right here, your greater than sign, and see what happens. When I divide both of those by 2, guess what? The sign stayed the same. It didn't change directions. If you multiply or divide both sides of an inequality, you treat it just like an equation. Both by a positive number, you treat it just like an equation. Let's try another one here. Now we're going to take this value here, and we're going to divide that number by 2. And what are you going to see? Same thing. Sign doesn't change direction. Moving on to another problem, another example. Write an inequality that compares the amount of money that Lamar has compared to the amount that Oscar has. Well, Lamar has less than Oscar, so Lamar is going to be $3.16 compared to $3.88. I missed my decimal back here. That's going to check. All right, so we've got that inequality set. And now when we graph it, what's going to happen if I was to triple at both of them? Multiply both of them by 3. Watch your inequality symbol down there, and nothing changes. Oscar still has more money than Lamar does every single time. If you multiply or divide both sides of an inequality by the same positive number, the inequality does not change directions. And we actually have a property that says just that. It's called the division property of equality. Actually, we have 2 of them, and we have the multiplication property of an inequality. Both of them stay the same basic thing. An inequality remains true when divided or multiplied by the same positive number on each side. Looking at that in symbols, if A is greater than B, then A divided by C is greater than B divided by C, and A times C is greater than B times C. It's the same, it works the same for the less than problems. And then if you wanted to look at them with actual numbers, if 9 is less than 15, 9 divided by 3 is 3, 15 divided by 3 is 5, guess what? 3 is still less than 15. And it works the same for multiplication. The multiplication and division property of an equality, very similar to, in fact, almost identical to the multiplication and division properties of an equation. So let's start solving one of these. We got a really simple one to start off with. It says 8 times x is less than or equal to 40. So to solve that problem, all we have to do is isolate the variable. The variable is x, his friend is 8. 8 is multiplying itself times x, and we undo times 8 by dividing 8 on both sides, which is exactly what you see going on right here. Next, the 8's on the left divide each other out, leaving x. The less than or equal to sign stays the same, and on the right-hand side, 40 divided by 8, that's going to equal to 5. So your answer, of course, is going to be x is less than or equal to 5. Very easy to do these. Works just like an equation works. There is no difference at all. Next, to graph that number, we need to graph x is less than or equal to 5. So I'm going to come down, and it's an or equal to. It gets a solid circle. We're going to start at 5 and go in the less than direction. Hit check, and the answer checks. Once again, super easy. We've been doing these for the past couple lessons. There's nothing new as far as the graphing of them goes. And now it is your turn. Go ahead and pause the video, solve this one on your own. It involves some decimals in here, so you might need to do some scratch work off to the side. Do that now. Alright, the final goal of any equation is to isolate our variable. The variable is y. Y's friend is 5/10, and we're going to make 5/10 go away by dividing it on both sides, undoing the multiplication. These are going to divide out, becoming 1. 1 times y is y. The less than sign does not change direction. And then we need to do a little bit of grunt work over here. 4.5 divided by 0.5. The decimal outside the house bounces to the right till it hits the wall. The decimal inside the house bounces the same number of spaces to the right and then goes straight up. And from here, 5 goes into 45 9 times. 9 times 5 is 45 with nothing left over. So our answer is going to be y is less than 9. But I'm thinking the textbook might have flipped that around. They did. If if 9 is less than y, that means that y has to be greater than 9 for our answer. We'll plug that in. Then we're going to take and graph it. We're going to take and use an open circle because it's not an or equal to. Our solution said y was bigger than the 9, so we're going to start at 9, and we're going to drag to the bigger side and let go. And that's all there is to do on that. Our answer checks. Easy math. You can totally do this stuff. I have total and complete faith in you and your ability on this. But what if we had a problem that involved division? How would that affect things? Well, works the same way. So here I've got d divided by 2 is greater than 7. Final goal of any equation is to isolate your variable. It's the same thing for inequality. Your variable is d, his friend is 2. 2 is dividing itself into d, and we undo divided by 2 by multiplying 2 on both sides. Now remember what I always tell you, don't do what the textbook's doing and sticking it on the front. Always put it after the number you're multiplying it by. The 2's on the left will divide each other out, leaving d, and on the right hand side, 2 times 7, that's going to be equal to 14. The answer checks. D is going to be a value greater than 14. Now we need to take and go and graph it, I suspect. It's greater than, not or equal to. That means we're going to be using an open circle right here. D is bigger than 14, so we're going to take that open circle and we're going to drag the arrow to the right and check our answer. The answer checks. Easy math. You can totally do this stuff on your own. And now you get a chance to prove that to me. Solve this inequality, graph the solution if it asks for it. It does. Check your answer, see how you're doing. So my problem has y divided by 3 6/10 is less than a negative 2. We undo divided by 3 6/10 by multiplying 3 6/10 on both sides. And I'm going to do it the right way. I'm going to put it after, just like I've taught you to do, is less than a negative 2 times 3 6/10. Over here, those divide out becoming 1. 1 times y is y. We leave that sign alone, and 2 times 3 6/10 is going to be, let's see, 6, 7, and 2/10. A negative times a positive, that's going to become a negative. So we jump back over here, and we're going to say that it's going to be less than a negative 7.2. Check your answer, and it checks. To graph that, we're going to start at the negative 7.2. It's an open circle. It's less than it, so the arrow is going to go to the less than side. Check our answer, and it checks. That is showing your work. That is what I must see. But what happens if we multiply or divide both sides of an inequality by a negative number? This is the one situation in which it does not work just like an equation. This is the only circumstance involving inequalities where the rules change. Everything else, you treat it just like an equation and you're done. This one has one teeny tiny difference, and we're going to take a look at it. So here, we're going to use our web sketch pad again, and this time we're going to say, suppose you were given 4 is equal to 4, and you divide or multiply both sides by the same negative number. Do the two sides remain equal? Well, if I multiply it by negative 3, and they remained equal. If I divided by -2, they remained equal. They made a flop sides of the graph, but they still remained equal. They were still equivalent. However, if we were to take and, all right, that's not the one we want. Let's see here. Boom, 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 boom. Now we're going to create an inequality. So we're going to grab one of these markers. So let's take and just make that be equal to 8, twice the value of the 4. And now what happens if I multiply? Now watch your negative sign here, or your inequality sign right here. If I multiply both sides by -3, look at that. That inequality sign, it changed directions. If I divide both sides by -2, what's going to happen here? Oh, I got to reset it. Let me see how to reset it. There we go. Boom. We're going to reset. We're going to go back to our 8 right here. And we'll call it right about there. If I divide both of them by -2, did you see that sign change direction again? And the graph explains why. When we had it the other way, you had the bigger number was going to be the one on top, the blue one. When we divided both sides by the negative, now the greater number is going to be the shorter stack because you're dealing with negative numbers. So the shorter number is going to be the one furthest to the right on the number line. And that leads us straight into the actual rules we have going on. In words, when you divide or multiply each side of an inequality by the same negative number, the inequality symbol must be reversed. And we saw that as a sign flipped in the graphs we were just playing with. If we were to take and look at that in symbols, you can say if all numbers A, B, and C, where C is not equal, where C is less than 0, if A is less than B, then A divided by C is going to become greater than B divided by C. This sign changed direction. Same thing for multiplication. Same thing if you end up starting out with a greater than and looking at it in numbers. 18 is greater than -12. You divide both of them by -3. See how that sign changed directions? And it gave us a true statement here that -6 is now less than a +4. Same thing here. -4 was less than 5. Multiplying both by -3, now we get a +12 and a -15. That sign has to change directions for the inequality to remain true at that point. And that leads us straight into an animation where we're going to learn a little bit about how to do these.
What happens when you divide each side of an inequality by the same negative number? To find out, start by graphing each side of a numerical inequality, such as -6 is less than 4. The number line shows that the inequality is true because -6 is to the left of 4. Next, divide each side of the inequality by a negative number, such as -2. Then simplify each side. To check whether the new inequality is true, graph each side. The new number line shows that the new inequality is not true because 3 is to the right of -2. So 3 is greater than, not less than, -2. To make the new inequality true, reverse the inequality symbol. This pattern is true whenever you divide each side of an inequality by a negative number. You must reverse the inequality symbol to keep the inequality true.
Okay, that's pretty straightforward. Let's see what else they have in store for us. So will the inequality symbol need to be reversed in this problem where you're taking and dividing both sides by +3? The answer is no, it won't. Because here, although there is a -9 in the problem, that -9 is not being multiplied or divided. What's being multiplied or divided? A +3. And because you're dividing by a positive number, the sign is not going to change direction. Now let's take and watch another animation that's going to talk to us about how to work multiplication problems, inequalities involving negative numbers.
What happens when you multiply each side of an inequality by the same negative number? To find out, Start by graphing each side of a numerical inequality, such as -2 is less than 4. The number line shows the inequality is true because -2 is to the left of 4. Next, multiply each side of the inequality by a negative number, such as -1. Then simplify each side. To check whether the new inequality is true, graph each side. The new number line shows that the new inequality is not true because 2 is to the right of -4. So 2 is greater than, not less than, -4. To make the new inequality true, reverse the inequality symbol. This pattern is true whenever you multiply each side of an inequality by a negative number. You must reverse the inequality symbol to keep the inequality true.
And there you have more mathematical proof about why you need to flip the signs when multiplying or dividing both sides of an inequality by the same number. Now, this is a great place to end part 1 of this lesson. When we come back, we're going to actually start applying these in part 2, where we're going to be working some inequalities involving multiplication and division of negative numbers. I will see you in part 2.